Alright friends, welcome back. In this video we're going to go ahead and move on to a third day for section 4.3 of your textbook and continue to talk about conic sections. And in this video specifically I want to go ahead and take a look at a specific shape that we get by cutting up a cone in a different way than the ways that we've seen in the past. So we have already talked about how to take this double napped cone here and cut it so that it makes the shape of a circle, and also cutting it so that it makes the shape of a parabola, as you can see here. But what I want to do here is go ahead and introduce you to a different shape. So let's go ahead and do that by just tilting my circle cut ever so slightly so that it looks like I make a cut that looks a little bit like this. And so this shape, it looks like is a round shape, but it does not necessarily look like a circle. It looks like a circle that's been stretched out a little bit. And so we actually go ahead and give this shape a different name completely, and we call this an ellipse. Okay, and so because this is a different shape that we get by cutting up the cone, this is also considered to be, again, what we call a conic section. And so that's going to be the point of the video today, is to be able to talk about conic sections and then just kind of giving ourselves a little bit of background about how we might go ahead and draw a graph of the equation of an ellipse. So it turns out with an ellipse, there's a lot of different terminology that I just want us to be familiar with as we go through and talk about ellipses. It turns out that another way to define an ellipse is that you go ahead and strike these two definite focus points right here. So you notice in this picture we call them F1 and F2. And what I want you to do is take a look at this dashed line here as a little bit of a piece of string. And think about these focus points as there being some thumbtacks, and I've got this piece of string that exists between my two focus points here. And I just go ahead and pull that string so that it's taut, and then drag a pencil tip along that string to create this entire shape here. That's what we would call, of course, an ellipse. And that's how we would define it mathematically, is that D1, that distance, and D2 are always going to add up to the same thing no matter what point on the edge of your ellipse you are at. And whenever we get to graphing the shape of an ellipse, we want to go ahead and point out some different terminology here. So what we say is that instead of a circle that has this nice even distribution all the way around, we have two different axes upon which we would draw an ellipse. And so the longer one is something that we always call the major axis, and the shorter one is always something that we call the minor axis. Okay, so you can see that I've got two straight lines drawn inside of my ellipse there that meet perpendicular at 90 degrees, and where they intersect is something that we actually call the center of the ellipse. So that's what you might think it might be, is the exact middle of the shape, right? And then what we do is we go ahead and give some names to the endpoints of these axes. And so V1 and V2 here, these are the endpoints of the longer major axis. We call those vertices. Okay, so the vertices of the ellipse, and then we also go ahead and strike this difference between the vertices and what are called your co-vertices. And that's why you see that I've got some points there highlighted in purple, or drawn in purple, I should say. And I've labeled them CV for co-vertices. Those are the endpoints of your shorter minor axis, okay? And we point these out because these are going to be things that they're going to ask you to find as we move on to some examples. So here when we take a look at the standard equation of an ellipse, just like we saw for parabolas, there are going to be two different cases based on if you want a horizontal looking ellipse or a vertical looking ellipse, okay? And so if we take a look at these two cases here, you'll notice that in case one, this is going to be the case that gives us more of a horizontal looking ellipse. And then in case two, this is where we're going to have a more vertical looking ellipse. And if you take a look at these two equations together, then you may notice that there's really not much of a difference. Some key things that they do have in common are that they do involve these two variables here of h and k, and these are variables that we have seen for a while now. These, of course, are going to be the center of our ellipse, just like we saw for circles and how we saw for parabolas. So that's pretty business as usual here, but you'll notice that the difference between these two equations is that we have these two numbers a and b, and it looks like in case one we have a sitting underneath x and we have b sitting underneath y, and then in case two we have the reverse of that, right? So b is the one sitting underneath x and a is the one sitting underneath y. And so these numbers a and b are going to be the numbers that determine what case you're in. And so the way that you tell is basically you go by this statement up here. What we always do here is we consider a to be the bigger number always, okay? And so another way to kind of distinguish between these two cases is by looking and seeing what a is sitting underneath. Because what this means is that if the bigger number is sitting underneath, say, x in case one, remember that a is always the bigger number, then what that is going to mean is that your ellipse is going to have more emphasis in the x direction, which of course is horizontally. Whereas in case 2 over here, if remember a is the bigger number, if the bigger number is sitting below y, then that means you're going to have some more emphasis in the y direction, or in other words, vertically, okay? And so that's how we distinguish between these two cases, is we take a look at what's playing the role of a and b, and then depending on which, x or y the bigger number is sitting underneath, that is going to determine what case we are and if we're a horizontal or vertical parabola, okay? And so as you look throughout the rest of these formulas here, basically they all involve a and h and k and b, but instead of actually using these formulas, I'd like to go ahead and take you through some examples where we're actually going to be using the graph to find a lot of these different characteristics here. And so, as always in the video here, I have a couple of examples already done out and a couple we'll do together, but here in the directions, they just want us to go ahead and write the following equations in standard form, that is, if they're not already, and then we need to go through and find all the different characteristics of an ellipse. So we need to find the center, we need to find out the lengths of the major and minor axes, and then we need to go through and find the vertices and the covertices. And so, if we take a look at part A here, it looks like we have y squared over 25 plus, x squared over 25 plus y squared over 9 is equal to 1. And you notice what I have written underneath is just the standard form, okay? So if we take a look at what we have, it's going to be a little bit harder to recognize how these forms match up unless you take your equation you were given and maybe rewrite a little bit. So because all it says is x squared and y squared, what we can infer from that is that playing the role of h is going to be the number 0. Okay, so I could rewrite that as x minus 0 squared over something plus y minus 0 squared over something is equal to 1, okay? And then matching up forms, it looks like playing the roles of h and k are both going to be 0 there. And remember that h and k, those are the coordinates of your center. So immediately one thing we know is that the center is going to be at the point 0, 0 in this example, okay? Now, taking a look at the numbers playing the role of a and b, it looks like sitting underneath the x squared is a 25, and that is a perfect square number. I can rewrite that as 5 squared, and then the number sitting underneath y squared is going to be 9, and that's something that I could rewrite as 3 squared. And so keep in mind that the numbers playing the role of a and b are the numbers that you square to get these quantities. And so a, it looks like is going to be 5, and b is going to look like it's going to be 3. Okay, so just kind of keeping track of some information here. I know that h is 0, and I know that k is 0. And then further, I know that a is being played by 5, and I know that b is being played by 3. Okay, so kind of going with the analysis that we talked about earlier, we know that the bigger number of the two, between 5 and 3, of course, is going to be 5. And because that's sitting underneath your x, that means you're going to have more emphasis in the x direction than you do in the y direction. And so what that's going to mean, of course, is that you're going to have a more horizontal-looking ellipse in this example, which of course means that we are dealing with a case 1 ellipse. Okay, so as we go through, we might just go ahead and do our analyses based on the formulas that are presented up in the notes in case 1. Okay. So I'm going to go ahead and show you how I go ahead and find the rest of these characteristics, and it actually is going to be by looking at the actual graph here, okay? And so I'm going to go ahead and draw this graph in the exact same way that I encouraged you to draw them for circles and also for parabolas. I'm going to go ahead and find the very middle point of my grid and then draw everything on top of that, okay? And so this is a 16 by 16 grid. I'm going to give you some bigger grids to work with for ellipses because typically your numbers are going to be a little bit bigger. So I'm going to go ahead and find the exact middle of my grid, which that's a 16 by 16, so I'm just going to count 8 in and then 8 from the top or the bottom and place that point there. That's going to be my center, okay? And so from the center point, I'll even label it, capital C for center. I'm going to go ahead and draw everything else, all right? So how I do that is I go ahead and acknowledge over here yet again that playing the role of A is 5, playing the role of B is 3, okay? These are actually going to be the distances that I'm going to use to draw my major axis and my minor axis respectively. Again, because 5 is the bigger number and it's sitting below x, I know that from my center point, I'm going to go ahead and sprout out to the east and to the west a matter of 5 grid squares from the center. Okay, so I'm just going to start at my center here. I'm going to count 5 to the west and then count 5 to the east and place those 2 points, okay? Again, how am I getting those? That is just the length of whatever A is, okay? So that is going to be my major axis. It's going to be my longer axis. And again, I place those points according to what A was. In this example, A was being played by 5, so that's how many grid squares I counted to the east and to the west, okay? And so Continuing here, what I'm going to continue to have is I'm going to have my minor axis. And the way that we get that is we go ahead and we take account of what this B number is. And that, of course, is 3. And so that's going to be the number of grid squares I'm going to count to the north and to the south. So I'm going to count up 3, and then we're going to count down 3. And that's where we're going to place our vertices there, okay? And so keep in mind that the endpoints of your major axis, these are what we call your vertices. So I'm just going to label those with capital V's. And then the endpoints of your minor axis, that is going to be your co-vertices. And so I'm going to label those with a CV on both, okay? And so now we have this nice framework upon which we can actually just go ahead and draw the ellipse. And if you really want to, you could just go through and freehand this. But I have a little bit of one-note magic here, so I'm just going to take this ink to shape, and I'm just going to go ahead and place it a little bit nicer on top of my vertices here, just kind of playing with how they're spread out so that they pass through all 4 points really nicely, and that is a perfectly drawn ellipse right there, okay? If you have to freehand it, if you're just working on paper, that's completely fine. Just maybe sketch it in or just do the best you can, all right? And so that is actually a picture of our ellipse, and the only thing left to do now is we're going to go ahead and get those axes drawn in there. So I'm going to go ahead and take my straight edge here, and this is going to work the exact same way as it worked for circles and also for parabolas. I'm going to count backwards from the center of my ellipse, okay? Now, it turns out that that's going to be a pretty easy thing to do here because in this example, playing the role of your center point is just going to be the point 0, 0. So we don't have to go really anywhere to place these axes. We could just go right to the center and immediately place our y-axis there. So we'll go ahead and place my y-axis there, and then we'll put this more horizontally and draw my x-axis there as well, okay? Again, just like we saw for circles and parabolas, we're going to have to, in other examples, count backwards from where we place the center so that we can go ahead and place the origin correctly, okay? But that would be a complete picture of the ellipse graphed in the xy plane. And so using this picture, I'm going to go ahead and get all of the other characteristics here, okay? And so the length of the major axis is something that we have to figure out. And you can use the formula from up in the case 1 formulas if you want, but because I have the picture drawn here, I could just go ahead and count how long my major axis is by counting the grid squares. And of course, that's going to be a length of 10 as I go throughout. So my major axis length is going to have a length of 10 units here. For my minor axis here, that is going to be something I can also count. So that's going to be the shorter axis of my ellipse. It looks like that's going to be 6 grid squares long. So we'll say 6 for my minor axis. And then what we need to do for vertices and co-vertices is list out the coordinates of these points. And you can see because I've already drawn the axes on top here, these are really easy to do. I simply have the point over here, go to the right 5, go up or down 0, go to the left 5, go up or down 0. Those are my 2 vertices there, so I'll go ahead and write those points down with coordinates. So that's 5, 0 and negative 5, 0 respectively. And then for my, my co-vertices, right? So this would be the point where I travel up 3 and to the left and to the right 0, so that would be the point with coordinates 0, 3, and then down here that would be 0, negative 3 to plot that point correctly. So I've got 0, 3, and then 0, negative 3. And so that would be a complete problem, okay? So basically taking a look at your example that was given, comparing that to the standard form equation for an ellipse, and then picking out those values of h and k, and then a and b for an ellipse, and then being able to draw the picture, and then get the rest of your characteristics from there. Okay. To save time in the video, I've already gone ahead and done part B. So this would be an example of a case 2 parabola because you notice the bigger number is sitting underneath y in this case instead of the bigger number sitting in, underneath x. Okay, and so that means it's going to have more emphasis in the y direction. So it's going to have a vertical ellipse shape to it, okay? And so we basically just plot the center of our ellipse right in the center of our grid, and then we draw everything on top of that. Keep in mind here that the center is now going to be at the coordinates 4, negative 3, so we have to, of course, work backwards from the center to place our origin point correctly. So that would be working backwards, maybe going up 3, and then to the left 4 to place that, that origin correctly so you can place your axes correctly. So what I want to do is go ahead and do part C from scratch here, because you notice that part C has an equation that doesn't look anything like the standard form equation for an ellipse. So we're going to have to work with this a little bit so we can rewrite it into that form, okay? And the way we're going to do this is going to be the exact same as how we did it for circles and how we did it for parabolas. We're just going to go ahead and do some completing the square. But you might look at what we have here and scratch your head a little bit, because we have so many different terms here, and we have terms that have x next to them and terms that have y next to them. What I'm going to do first is go ahead and reorganize here. So I'm going to go ahead and highlight everybody on the x team in the color blue, and I'm going to highlight everybody on the y team in the color green. Okay, kind of begs the question, what are we going to do with this this very last team member here? It doesn't look like it has an x or a y next to it. Well, because it does not belong to either team, I'm going to go ahead and bring that immediately over to the other side here, and then rewrite my teams more grouped together, right? So we have my blue x team, so that'll be 9x squared minus 54x, and then we're going to say plus my green y team, so that'll be plus 4y squared plus 40y. And that is going to be equal to 0 minus 37 on the right-hand side, and that'll be negative 37, of course. Okay? So here's what we're going to do. Because we want something that looks an awful lot like x minus h squared and y minus k squared, what we're going to do is we're going to now complete the square with both of these two groups. Okay? But you may remember something about completing the square is that you actually don't have the green light to do it unless the number sitting in front of your squared term in both teams is the number 1, okay? And that's not really the case here. It looks like playing the role of the number in front of the squared term in the blue group is a 9, and that in front of the y squared term is a 4, and so that's going to be a problem. And the way we kind of work around that problem is we factor out a number from both groups, okay? So we're going to factor out a 9 from the blue group, and we're going to factor out a 4 from the green group, okay? We're going to factor out these numbers because those are the numbers sitting in front of your squared term in both teams, okay? And so for the blue group, that's going to leave behind x squared minus, and then remember you're factoring out a 9 from a 54, so that's going to leave behind a minus 6x, and then in the green group, you're factoring out a 4, so that'll leave behind y squared plus 10y, okay? And so now that you have the number in front of your squared term being just a 1, we're now going to go ahead and perform that completing the square step, okay? And so for the blue group, again, that is going to look like taking your number for b and dividing it by 2, squaring the result. That's going to be plus 9, okay? For the green group, it's going to be taking your number b, dividing it by 2, and then squaring. So that's 10 divided by 2, which makes 5, and then squaring that, that's going to make 25, okay? Now again, these numbers are ones that you have introduced fresh to the problem. These weren't here before. So what that means is because you introduced them to the left-hand side, you're going to have to also introduce them to the right-hand side. But I just want you to be a little bit careful here, because what you did is you introduced this plus 9 for sure, but you introduced it into this group where everybody was being multiplied times 9. And so what I'm going to have to introduce over to the right-hand side is whatever 9 times 9 is, and that, of course, is going to be 81 in this example, okay? And so in that way, you're going to have to be really careful about what you're introducing to the other side to keep things balanced. And then it's the same thing for the green group. You introduced this 25 for sure, but you introduced it to this group where everybody was being multiplied times 4. So you're going to have to introduce plus whatever 4 times 25 is, and of course that is 100. So that is just a step you're going to have to be a little bit careful about whenever you're completing the square in examples like these so that we don't make a mistake, okay? And now what we're going to do is clean this up a little bit, because in my blue group I completed the square, so I can go ahead and now rewrite this as 9 times the quantity x minus 3 squared, and then say plus 4 times the quantity y plus 5 squared. And that is going to be equal to whatever negative 37 plus 81 plus 100 is. You could go ahead and do that mentally or in the calculator. What you should end up here with is 144, okay? And so now you have something that looks a little bit better and closer to what it is you wanted. Now you have something that does look like x minus h squared, and then you have something that looks like y minus k squared. Okay, but you'll notice here that we don't quite have exactly what we were looking for, because if you come back up here to your standard equation, one of the most important things about this is that all this stuff on the left-hand side is actually equal to the number 1 in both cases. Okay, so the number that we have on the other side of our equation is not that number, okay? It's not even close to that number. It's a 144. It's not a 1, okay? But here's the thing. We can always take a number and turn it into the number 1 by dividing it by another copy of itself, okay? So that's exactly what we'll do now is we'll go ahead and divide 144 by a copy of itself, and that's going to give us the ability on the right-hand side to call that the number 1. Okay, but obviously that's something that I did to the right-hand side. I'm going to have to make sure that I do that same thing to everything on the left-hand side. And so I have to also do that same thing for my blue group and my green group here. I'm going to have to divide those both by 144. So that kind of begs the question, well, what does that mean for my blue and my green group here? I thought that those looked exactly the way that I wanted them to look. Well, what that's going to mean for us is that we're just going to have some fractions to reduce. In the blue group, you had a 9 on top, and now what we're doing is we're dividing it by 144. That's a fraction. 9 over 144 is going to have to be a fraction that you reduce. And I'm not going to demonstrate that here in this video. You could do that very easily in a lot of different calculators reducing fractions, but I'll just go ahead and tell you here that that will reduce to 1 over 16. And so in my blue group, I can go ahead and rewrite that as x minus 3 squared over 16. And then I'll say plus, and now we'll move on to our green group where we're going to have to do the exact same thing. We're going to have to reduce this fraction 4 over 144, and if you do that in the calculator, you're going to find that that's going to reduce down to 1 over 36. And so we'll go ahead and rewrite that as y plus 5 squared over 36. And now we have something that looks an awful lot like the form that we wanted, okay? And so if you check upstairs in your case 1 and case 2 standard equations, these is exactly what they both look like, okay? And so now that you have the form looking like what you want it to look like, we can now go through and pick out what's playing the role of h and what's playing the role of k. It's not going to be 0. I don't know why I wrote that. H and k, and we can also pick out what's playing the role of a and b, and then figure out what case we are. Are we case 1 or are we case 2? All right, so taking a look here, basically the simple way for you guys to be able to pick out what these numbers are, guys, is look at the sign in front of these numbers and then change it whenever you declare what h and k are, right? So here I've got a minus 3, so I'll say that h is being played by positive 3, and then I've got a positive 5, so I'm going to say that playing the role of k is a negative 5, okay? And keep in mind that h and k are really important because that is exactly the coordinates of your center. So I'm going to have a center point here at 3, negative 5. Now moving on to a and b, we obviously are going to be looking at these numbers that come underneath, and we're going to notice here that 36 is obviously the bigger number, and that's sitting below y. And so what that's going to mean is that we're going to have more emphasis in the y direction, and so this is going to be an up and down looking ellipse whenever we go to draw it later, okay? And so that, of course, is going to mean that we have ourselves a case 2 looking ellipse, okay? And so the numbers that you square to get 16 and 36, of course, that's going to be 4 squared and 6 squared respectively. A is always the bigger number, so that means that playing the role of A is going to be a 6, and playing the role of B is going to be 4, okay? And so again, once you have these values, now what we'll do is we'll come over here to the grid, and we'll start drawing that picture. We're just going to go ahead and draw our center point right in the center of our grid. And then again, because we have a case 2 ellipse, one that looks a little bit more like a vertical ellipse, we're going to use our bigger number, which is going to be 6, and we're going to count to the north and to the south in the vertical direction, okay? So I'm going to count 6 north, plot, count 6 south, plot, okay? So we've got my center point here, and these are going to be the endpoints of my major axis. Remember, we call those vertices, and so I'll go ahead and label those both as capital V, okay? And now playing the role of my other number, B, is going to be 4 here. So I'm going to go ahead and plot 4 to the east and plot 4 to the west. That's going to be my co-vertices because those are the endpoints of my minor axis. And then again, those of you who are doing this on paper, you're just going to have to go ahead and approximate what the sketch would look like. But because I am working within OneNote here, this is something that I can actually go ahead and just draw myself a nice simple circle and then just change the dimensions of that by dragging the points here, okay? And so there is a quick way to go ahead and sketch your ellipse. Again, just doing it by hand the best you can is is good enough, okay? But now what we need to do is go ahead and draw these axes in here. And we remember that the center point in this problem is going to be at the point with coordinates 3, -5. So that means working backwards, that's where I'm going to have to place my origin. So if I have the point with coordinates 3, -5, that means I'd have to, from the origin, travel 3 to the right and then 5 down. So what I'm going to do here is I'm going to go ahead and work backwards here. I'd have to go 5 down to get to my my center point, and then I'd have to go 3 to the right, okay? So if I work backwards from that place, I know that right here is actually going to be where my origin is going to sit, and that is going to be where I'm going to put my axes, okay? So I'm going to go ahead and draw my x-axis in there, and then go ahead and draw my y-axis in there. There we go. Okay, so working backwards from your center point is a really easy way to go ahead and plot those axes correctly. So this is going to be my y-axis, here's my x-axis, and here's the origin point, very simply. Okay, and so now using this, we can go ahead and get all the different characteristics of our ellipse. We can count that the major axis is going to have a length of 2 sets of 6, or in other words, a length of 12. Our minor axis is going to have a length of 2 sets of 4, which is 8. And then we could just go ahead and look at our plot to determine the coordinates of all these different other points here. So for my first vertex, I'd have to go 3 to the right and 1 up. And so, of course, that's going to be a point with coordinates 3, 1. And then the other one, you might have to count the grid squares here, but that's going to be 3 to the right and then 11 down. So that'll be 3, -11 for the other vertex in this picture. For my co-vertices, the endpoints of my minor axis, again, just counting the coordinates out, the first one is going to be go 1 to the left and then go down 5, so that'll be -1, -5. And then for the other co-vertice, or co-vertex, I should say, we have to actually go 7 to the right and then down 5. So that'll be the point with coordinates 7, -5. Okay? So there we go. A quick picture of what an example would look like if the original equation you were given does not look like your standard form equation for an ellipse. We're going to have to complete the square. So to summarize that process, we're going to get all of our x stuff together, get all of our y stuff together, make sure that you factor out a number in both of those teams so that the number in front of your squared term is just a 1, and then you have the green light to cut that b term in half and then square the result and then continue from there. Here's a quick snapshot of what the fourth example would look like from the notes, and you can see here that this is going to be a case 1 ellipse, one that looks a little bit more horizontal, has more emphasis in the horizontal direction. And that, again, is because whenever you go ahead and convert the equation, you're going to have a number underneath y that is sorry, not underneath y. You're going to have a number underneath x that is bigger than the number that's underneath y, and so that is why we have more emphasis in the x direction here, okay? Going through, plotting the center, and then going through and plotting all of your different points here. So here's where your center would be. Your vertices would be the endpoints of your longer axis, your major axis, and then your co-vertices would be the endpoints of your minor axis, so your shorter one there, okay? So go ahead and pause the screen, read through that work there, and make sure that you're able to make some sense of that, and then that's actually all I have for this video. So thank you very much for your attention. I know that we talked about quite a bit here. There's just a lot of different characteristics of these conic sections to have to keep track of, but hopefully that all makes sense. If you guys have any questions, then as always, feel free to let me know. That's all I have for this one. Thank you very much for your attention, and I will speak to you in the next one.